Hello all and welcome to my YouTube channel. So today in this particular video we are going to discuss how we can train our own custom tokenizer for our own training data set. So we all have been using Bird tokenizer, Roboto tokenizer, GPT tokenizer, which were trained on English language, and we were able to use that tokenizer to encode our text data. So let us understand what does this first tokenizer means. Tokenizer means that you have the text data and you want to convert into the numerical format. So that's where the tokenizer will help you to convert the numerical data into the you can convert the language data into the numerical data. And this tokenizer should also consist of the information about the particular word, right? So what it does is generally split up the sentence into the words and tokenize into the words, and then it further splits into the subwords and unigrams and bigrams, and then try to form a numerical representation for such kind of splittings, and then form a tokenizer. So that's what tokenizer does at the back end, and then that's how it's gonna give us a different representations of a particular subword, n-gram, or tokens or words, the representation of those numerical formats, right? So that's what the tokenizer does at the back end. That's part of our tokenizing, and that's how the tokenizer gets trained. So initially you just give a English data and you get a numerical representation for that English data. That's how generally you have seen, but we have also seen the tokenizer for different languages. We have been using, like, for Spanish, for Hindi, for other French languages and German languages. But did you imagine how those tokenizer got trained? How those particular tokenizer got trained on those language? And so that's what we are going to look upon it in this video. So in this particular video we are going to train our own tokenizer by using a dataset which will be on different language, which will be on Latin language, and that's where we're going to train our tokenizer for the Latin language. So we'll see the whole steps, how it's going to progress, and how we're going to train it on the language dataset that is on the Latin language. And we'll also discuss how we can train and use that tokenizer, our trained tokenizer, on the dataset to tokenize the data. So first let's see what kind of data set we are going to use and where we can find such kind of data. So Hugging Face has provided a very good data set library. If you go on their site, and you can just go on to their data sets, and you can find a lot of data sets available for different language, for vision models, for English language, for Hindi language, for all such kind of languages. They have all sort of data set available. So in Hugging Face site, you can go and check onto that data set toggle, and you can just get all the necessary required data sets, right? So for this particular tutorial, I am going to use the Latin data, and it is available inside the Oscar dataset with the Latin language. So on the screen you can see this particular data set, right? So I've just gone through the data set and found out there is a data set available, Oscar, and inside that we are going to use this Latin data set. If you just go into this particular, you can find more data set available for different languages. Like if you want to go for African, you can just select this one, and if you want to go for German, you can select this DE1. If you want to select for English, you can select EN. So likewise, there are many datasets available here in this particular Hugging Face Oscar. And how you will get to know that which language, which data is available? So you can just go onto the Oscar site, and if you go onto the Oscar site, you can just scroll down, and you can check that there are various languages and there are various data set available. So you can see there are Oscar 2019, Oscar deduplicated, Oscar 20.09, and Oscar 21.09 deduplicated. So a lot of data set available with the name of Oscar, and their versions has been improved on the daily basis. And We have different languages available here. You scroll down, you can see the language and its a representation in the short form. So there's a short form you were able to see here, here like underscore LA, which represents for Latin. So if you go to this Oscar site, you can see there is a LA, which will specify that it is Latin. So you can see it's Latin, and there here is the size of this particular data set. So you can see there are a lot of data set available. There are a lot of text available for this Arabic, like 33 GB of file is available, and even for duplicate 35, 69 GB. So a lot of data available for for the language which are relatively available, which are relatively spoken. So for that, the data is very much huge, and uh, it's also been shown here in the particular Oscar data set. So they have got a lot of data with respect to each language. So why I am going for Latin? Because if you go to the Latin, the data size is very less. It's like 8 MB, and for this tutorial I don't want to use huge data. I just want to show up the process. I don't want to go on to the training of huge data set. So I'm just taking up the Latin language, and it's a 8 MB file. So we can use this 8 MB file, and we can understand and train our tokenizer for our tutorial purpose. Later on, if you want to train for any other language like Japanese or Italian or any other Indonesian language, you can use this kind of data set to train your own tokenizer, right? For but just for this particular tutorial, I'm going to use the Latin because of the strain size constraints. Because as soon as you increase the size of the data set, the training will take a lot of time, and it can take like 1 day or 2 day also. So I don't want to progress in that manner. So just for this tutorial, I'm going to stick with the Latin, which is of less size. So seeing that Latin is of less size available, so I'm selecting the subset folder available in the Hugging Face dataset site, and I'm selecting this particular subset from the Oscar, and we're going to train the model on this particular dataset. So you can see for each and every text, we have the respective ID. So that's how the texts are being given. So now we'll import this particular, or we'll download this particular dataset onto the our collab notebook, and we'll see how we can train Latin tokenizer, right? So let's move to the collab, and we'll see how we can do that particular training. So let's start with the import of the data, right? So for that, we need to install the dataset which is available on Hugging Face. So we need to install that dataset. So the easiest process is to pip install datasets. That will connect to the Hugging Face dataset that we just looked upon, right? So that's how we're gonna install this datasets. And now we're gonna import the datasets, and we'll see the list of the datasets available over there on the Hugging Face site. So it's directly connected to the Hugging Face dataset to get to know what kind of datasets available over there. So you can see it's like near to 8,000 datasets available right now. So let's see some of them. Now you can see that there are various datasets available. You can just go through those sites and you can just visualize it perfectly. Here I'm just showing it for demo purpose. Now we have to download the dataset that we just talked about, right? We have to download this unshuffled deduplicated LA, which is from the Oscar, right? So for this, we are going to use this dataset dot load dataset, and we are going to specify the Oscar dataset, and from this Oscar we want to download the LA, that is the Latin one, right? So we are going to download this unshuffled deduplicate Latin dataset, and we are going to store it. So that's how we are going to download it. It will take few seconds to download it because it's very less of in size. And now we're gonna just take up this dataset, and we'll see how many rows are there. So you can see there are 18,808 rows available, and we have ID and text respectively. Now we're gonna view a single row of this training dataset, and you can see that it's a you can see it's clearly a Latin language that we can see. Like if you go to this particular site, and you can see that it is printing the same text here in here, right? This is the same text you can see, which is present on the side, right? So now we are ready to see that we can see that the data we have is here, and now we want to just take up this data and train a tokenizer. But before moving into that purpose, let's just split this particular data set into different chunks. So what I mean is, what we're trying to do is, we have, let's suppose, how many rows we have. We have 18,808 rows, right? Now we want to split this whole rows into different chunks, like 5,000 chunks a file will create separately, 5,000 chunks file will create separately. Likewise, we'll create a different files uh, for each row. So we'll divide this 18,000 rows into four files, and each file will have 5,000 rows of data. And that's what we're going to do is, and we're going to save those files in the text format. So this code is all about that only. So we'll take up this data, and we'll specify the length of the text, that is the rows, 5,000 rows, and we're going to save it. And similarly, once the files are saved, then we're gonna take up these files and train our custom data. So let me just create a folder called data, because we are going to save all the text files that we're going to prepare it from here, all the chunks text file that we're going to prepare from here. So let me run this particular cell, and it will save all the text files. So let me show that what I meant to say. So you can see our whole 18,000 rows has been divided into the four text files. So if I open one text file, you can see, or you will be able to see all the data that we talked about is here in this particular text file. So it is taking a lot of time because it's loading 5,000 rows. So yeah, you're able to see, right? So it's taking all the text files, all the text, and we have 5,000 rows. If you go scroll down, you will be able to see this 5,000 rows available, right? So that's how the things are, and we are able to see. You can see the first index that we just printed out in the collab notebook. It's here. So that's how we have divided all 18 rows into the different four files. And why we did that? Because for our training purpose, we don't want to focus. We want to just split up the things into the different sections. What happens is, when we have large data set, right, like GBs of data set, then you don't want to train it on like lakhs of data set, right, lakhs of text files, because after some time the words start repeating. So what we generally do is, when we have a huge data set, you just split into those different chunks and try to train on sub chunks, not on the whole data. You just try to train on sub chunks, because the training time is very large when you go for such huge data set of training. So that's why this is a best practice. Once you get the data, you split into the text files and train on the certain files, not on whole data set, so that you get a maximum, or you do the random sampling of the text files and train on those data set, or on those text files. That will help you to generalize better and get the maximum tokenizer inputs for your for training a tokenizer model, right? So that's the best practice we generally follow, to split the data set into the text files and train for certain text files, not on whole text file. You can train it on whole text file, but it will take a lot of time to train model. Now once we have this text files available, right, now we will load this paths, or the path of this particular text file. So this is where we're going to run this particular we're going to use this path lib to just get the paths of this particular text file that we just created, the chunks of files. And now once we have this, we are just ready to train the model. So we just install this transformer library, and it will take few seconds to install. So let's wait for it. And once that is completed, we'll just look upon how many lengths, like how many path is there in the particular folder. So we have four particular text files. That's very that's been checked here. And now we are going to train our tokenizer. So we have a lot of tokenizer available in the tokenizer from transformer. Like we have Bird tokenizer, which is nothing but word piece tokenizer. So Bird uses word piece tokenizer, and Roberta model use byte level BP tokenizer, that is byte level tokenizer. So so the best thing which I have seen is to go for byte level pair tokenizer, because it split the text into it split the words into different sub chunks into the bytes at the alphabet level. So that's a very good way to deal with it, because it avoids the unknown token to be generated. But word piece tokenizer generally generate unknown tokens when the word is out of vocabulary. And here at the byte level pair encoding, generally it takes up a word and split up the text up to the alphabet level. So that's where the byte level pair tokenizer name comes from. So hence we are going to train a byte level pair tokenizer. You can also train word piece tokenizer, which you can directly import it from tokenizer, like how I'm doing. And you can train your word piece tokenizer algorithm, which is generally a BERT algorithm uses. Right now we are going to use byte level pair encoding, which generally being used by GPT, and which generally being used by Roberta model. So there are many models that are available which are using this BERT byte level pair encoding. So we are going to import this byte level pair tokenizer, and we are going to initialize this. And once this tokenizer is being initialized, we just have the method called tokenizer.train. So this is the train method where you have to specify the file paths. So you can see I have taken up this file paths. So these are the file paths. We are taking all these file paths, we are passing into this files argument, and we are specifying that how many numbers of vocabulary size you need. So we are going to say that okay, we need 30,000 of vocabulary size, and we need that's a minimum frequency of 2. That means that a particular token is coming up at least 2 times. It should be seen as 2 times if it is available on that particular text, right? In a particular sentence, how many times that particular token is coming. So we are specifying that limit as 2. So if that particular token is coming up 2 times, then you take those cut and those then take those kind of tokens and split into the particular alphabet level, right? And these are special tokens that are being used for byte level pair encoding, that we need to we have to specify it explicitly. There's no other way to specify, because that's a way of training how the tokenizer are being trained. So you have to specify the start of the token as this, you have to specify the padding of the token as this, you have to specify the end of the token like this, and you have to specify the unknown token like this, and you have to specify the masking of the token like this. So these are the special tokens that generally any kind of transform models has to take up. So hence this token specification has to be specified based on the tokenizer that you're using. So if we are using byte level tokenizer, so these are the tokens you have to use for training, right? So once these setups are done, the paths are specified, only thing you have to just start this training. So it will take few seconds to train, and since our data is very less, we have taken just 8 MB of data, and it should be able to train very quickly. But this is very very important to understand. Like if you have huge level of data, then this particular process training process will take a lot of time to train. It won't be just so quick that you are able to see on the screen. It will be very very long time that it's gonna take to train, right? So once we have this model trained, then we just refresh our console, and once this particular model is trained, we're gonna save this model. So we are going to just create a directory called LA Roberto, and we're gonna save this tokenizer by using save underscore model method, and then with the name of LA Roberto. So as you can see, it has created 2 types of file. It has created a vocab.json, and it has also created a merger.txt file. So let me just visualize this. What are the things are available here? So if you go into this LA Roberto tokenizer model, you can see that it has produced all kind of the tokenizers. You can see, right, all the kinds of tokens and words that are splitted and formed while using this particular tokenizer. So if you scroll down, since you have specified 30,000 vocabulary words, right? So you can see it has approximately created those many numbers of words by the vocabulary that you have given. So that's how it has created the vocabulary for itself. And now if you want to see the indexing of this vocabulary, so you can just visualize in this vocab.json file. So you can see it has all this tokens that was just created in the merger docs.txt files, and it has a respective encoding number has been given to them, that is a numerical number has been given to them. So this is the padding token that we gave, right? For tokenizer, that if you have to specify, so these are the special tokens that are being given, and it has been given some numbers to it. Similarly, what are the vocabularies that it has been able to learn? It is able to give the number to it. So that's how the vocabulary and the JSON file and the merger or text file are got trained by using the tokenizer, byte level pair tokenizer. And now we have to just see how the things will work, like how we can use this trained tokenizer that we have just created, and for like how we can use this particular, how we can load this particular tokenizer, and we can just encode our Latin text, right? So for this you have to use Roberta tokenizer from transformers, and you have to just use it in a Hugging Face format, like Roberta tokenizer fast dot from pre-trained. So there in from pre-trained you have to specify our model path, or our vocabulary path that we have created. So just you have to specify, and your tokenizer will be loaded. So let us run this particular code, and once your tokenizer is loaded, we are going to pass the particular sentence that we just saw at the top, right? Before encoding, like we printed out one text, right? The first part of it. So these are text, right? So we want to pass this particular sentence to a tokenizer, and we'll see the tokenized part. So once we have this tokenizer loaded, so we'll pass this sentence to the tokenizer, and we are going to specify the max length of 512, and we are going to specify the padding max underscore length, and we also provide a truncation underscore true, because we want to make sure that it shouldn't be more than this 512 token size, right? So we'll run this particular cell, and we'll see the tokenized part. So now you can see the particular tokenizer is returning input underscore IDs, attention marks. So this is how you're gonna create or tokenize the sentence. All these are padded tokens. So this is how we're gonna train the model, the tokenizer model, and how you're gonna load the model, the trained model, and how you can tokenize this. So these all the steps are being clearly, I think, being clearly very visible, and you can use this process to train on your own data set if you have, or you can also train on different kind of data set and on different languages, and you can just try to fix this kind of tokenizer issues if that occurs in the process of training. Now these things are very very simple to do. Only thing you have to remember is when you train on huge set of data, then it's gonna take a lot of time to train. So if you are going to train the tokenizer, leave it for overnight and wait for the training to happen. But these are the general steps that you can follow to train your own custom tokenizer for your own data set, if that particular data set is very very unique and it doesn't have that tokenizer available on the internet, and you can train it on your own, and then you can load it. You can load that particular tokenizer model, and you can tokenize your text. So these are the necessary steps you can follow to train your custom tokenizer by using Hugging Face. I hope you enjoyed this particular video. If you like my channel, do subscribe my channel. Thank you.